Good morning, everyone. Thank you for joining us. Welcome back. I'm Steve.
And I'm Scott.
Together with Backyard Musings, Apple Valley.
Yep, and we were talking about a planet today, an interesting phenomenon on a planet, which just came up last night in a conversation I was having with my grandkids that live up in Utah.
Got a hint from your grandson.
Yeah, so I got to dedicate this one to my grandson, Troy McCoa, and him bringing this to my attention. So here we go. We're going to talk about it.
I knew about this, but I didn't know the magnitude.
Yeah.
Olympus Mons, Latin for Mount Olympus, is a large shield volcano on Mars. It's over 13.6 miles high, as measured by the Mars Orbiter Laser Altimeter. So, I mean, it's got laser measurements.
Yeah.
About 2.5 times the elevation of Mount Everest above sea level. It is Mars' tallest volcano, its tallest planetary mountain, and is approximately tied with Rheasilvia on Vesta. I don't even know where that is.
I have no idea what
Vesta's not a planet. Is it a moon?
I don't know.
As the tallest mountain currently discovered in the solar system. It is associated with the volcanic region of Tharsis Montes. It last erupted 25 million years ago. Would you like to know more?
Yeah, to quote my other grandson that lives here, whenever I ask him a question, and his response is, I have no idea. So that's my response to your question there. I have no idea. Anyway, maybe we'll figure it out later. Being a shield volcano, Olympus Mons has a very gently sloping profile. The average slope on the volcano's flank is only 5%. Slopes are steepest near the middle part of the flanks and grow shallower towards the base, giving the flanks a concave upward profile. Its flanks are shallower and extend farther from the summit in the northwestern direction than they do in the southeast. The volcano's shape and profile have been linked to a circus tent held up by a single pole that is shifted off center. Yeah, because this thing is massive. At the base of it, you're going to show the slide.
Let's show it, yeah.
It's massive.
This is the bird's eye view, and it looks like it's a circus tent, like you said, and just shifted off center.
Right.
And if you've been to Hawaii on the Big Island, you know that Big Island is just like gradually slopes. It's nothing radical. That's, I imagine, what this would look like. But you wouldn't be able to see the entire mountain. It's the size of France.
Exactly. I was going to say.
We're going to show that a little bit later.
Yeah, it sits inside the size of the borderlines of France. It's amazing. So
a mountain that big.
Yeah.
Because of the size and shallow slopes of Olympus Mons, an observer standing on the Martian surface would be unable to view the entire profile of the volcano, even from a great distance. The curvature of the planet and the volcano itself would obscure such a synoptic view. Similarly, an observer near the summit would be unaware of standing on a very high mountain, as the slope of the volcano would extend far beyond the horizon, a mere 3 kilometers away. Dang.
Yeah, that's okay.
So you wouldn't know you're on a mountain.
Right. As a shield volcano, Olympus Mons resembles the shape of large volcanoes making up the Hawaiian Islands, like you just said. The edifice is about 600 kilometers, which is 370 miles wide.
That's the radius?
Massive.
No, that's the diameter.
Yeah, the diameter.
Wow.
That's massive.
Wow.
I mean, that's like from here to southern Utah.
Or France.
Yeah.
With the France.
Yeah, it's crazy.
Yeah.
Because the mountain is so large with complex structure at its edges, allocating a height to it is difficult. Olympus Mons stands nearly 22 kilometers or 14 miles above the Martian surface, growing to such heights primarily as a result of prolonged volcanic activity, weaker gravity, and less intense weather systems that cause erosion.
Okay, let's get to this next slide here. Here we go. This is how it's being compared to France. Yeah. This is crazy. And then you can see below is like a profile cut section, and you can see there's Everest over here, and there's Mauna Kea, but it's not giving it. I mean, it's like, is Mauna Kea floating on the ocean?
Yeah.
No, it's Mauna Kea goes all the way to the base of the ocean floor.
Yeah.
Get me started. Its local relief from the foot of the cliffs, which form its northwest margin to its peak, is over 13 miles, a little over twice the height of Mauna Kea as measured from its base on the ocean floor. The total elevation change from the plains of Amazonas Planitia, over 620 miles to the northwest, to the summit approaches 16 miles.
The summit of the mountain has 6 nested calderas, collapsed craters, forming an irregular depression, 60 kilometers by 80 kilometers, which I didn't catch that. It's about 37 miles by 50 miles across, and up to 3.2 kilometers or 2 miles
That's the
deep.
caldera, 2 miles deep. Man.
Yeah. And what is Everest is about 27, right? 27,000. So that's about 5 miles. So roughly about half. That's crazy. That's crazy. The volcano's outer edge consists of an escarpment,
like a cliff,
or a cliff,
crazy,
up to 8 kilometers or 5 miles tall.
Can you imagine looking up at that? Like, where does it go?
Right. A feature unique among the shield volcanoes of Mars, which may have been created by enormous flank landslides.
Breaking right off.
Yeah. Just chunk. Yeah. Splinters of it.
I wonder what the base looks like, all the debris and stuff from the fall away. Huh. Olympus Mons covers an area of about 120,000 square miles, which is approximately the size of Italy or the Philippines, and is supported by a 43-mile thick lithosphere. The extraordinary size of Olympus Mons is likely because Mars lacks mobile tectonic plates. Unlike on Earth, the crust of Mars remains fixed over a stationary hotspot, and a volcano can continue to discharge lava until it reaches an enormous height.
Yeah, we've talked about that. No tectonic plates over there.
Yeah.
Right? Mm-hmm. The typical atmospheric pressure at the top of Olympus Mons is 72 pascals, about 12% of the average Martian surface pressure of 600 pascals. I don't know what a pascal is.
It's the scientific. There's an imperial, but I forget pounds of force or something like that.
Well, if you know, let us know in the comments. Yeah. Both are exceedingly low by terrestrial standards. By comparison, the atmospheric pressure at the summit of Mount Everest is 32,000 pascals, or about 32% of Earth's sea level pressure. Even so, high altitude orographic clouds frequently drift over the Olympus Mons summit, and airborne Martian dust is still present. That must be maybe from all that junk falling up. Yeah.
But there's nothing to get it to, the dust just kind of stays up there. It's so light, I guess.
Right.
Although the average Martian surface atmospheric pressure is less than 1% of Earth's, the much lower gravity of Mars increases the atmosphere's scale height. In other words, Mars' atmosphere is expansive and does not drop off in density with height as sharply as Earth's. So there you have it.
Yeah, so really interesting. So maybe someday somebody will be able to visit this place, even if it's just a flyby. Wouldn't that be cool?
That would be really cool.
Yeah. Be able to get
that could be a tourist attraction. Right at those cliffs, man.
Yeah.
People trying to climb the cliffs.
Yeah. So anyway, great story.
Thanks for joining us, folks.
See you this afternoon. Thanks.